Welcome to the MasterCAM section of the Week 1 material. In the last video, we created a 3D SolidWorks representation of the fixturing setup that we are going to be using to create our code in MasterCAM. And this video is going to show you how to merge this file into MasterCAM, clean up the levels, create the planes, and perform the manufacturing operations that we need to do to finish creating the part. So we're starting now with a file called Simple Kurt Weiss, which is a solid assembly. You could have saved this as a different file name if you wanted to before we did all this, but now that we've set this all up, remember you don't want to modify the part names or the assembly names without causing issues. You'd have to relink everything. So make sure you know exactly what file you're looking for. We want to import the SolidWorks assembly into MasterCAM. I have already opened MasterCAM and I have a new file started here. What I'm going to do is a file merge to bring in the assembly and start working on our part file. So I'm going to go to File, Merge. Now remember, when you open up MasterCAM, it's going to be looking specifically for MasterCAM files only. So if you're looking to bring in a SolidWorks file, you're going to need to change that to SolidWorks, or to keep it really simple and easy, I select all files first. I'm going to navigate to my folder where the assembly lives, and I'm going to go ahead and select Simple Kurt Weiss. I'm going to click on Open, and it's going to bring in the solid file. All these pieces are separate, but we will need to do some different levels. You'll also notice the colors are all solid. For right now, I'm not worried about any of that, and I prefer to do my positioning outside of this main area, so I'm going to click OK, drop it in place, and actually you'll notice some of the colors came over, which is nice. And when we go into levels, you'll see that we do have some separate levels, but there are no names, and we're actually going to combine a couple of these two, so we'll clean that up later. The first thing I want you to notice, if we go to right click and click on top, the plane is actually 90 degrees out of whack, which is fine. We just have to do a simple dynamic to bring it into the correct orientation. I understand that we're going to create our own planes, so that the original orientation here does not matter all that much, but I still like to align it so that it's properly oriented to the main plane, or the original planes. So again, right click on top, that tells me we're 90 degrees out of rotation. So I'm going to go to Transform. I'm going to use Dynamic Rotate, or Dynamic Move basically. I'm going to select all my entities, and the easiest way to do that is a pick box, since we have 4 or 5 different solids here. I'm going to rotate around and make sure I have everything. Looks good. I'm going to end the selection. And again, I've talked about this in class, but I'm not worried about position right now. I'm only doing the rotation. I like to do them separate. So I'm going to click anywhere in space. I want to rotate the front of this vise basically underneath here. So we're going to use the axis between the Y and the Z. I'm going to click on the red radial button here to kind of highlight or to select it. And it grabs everything so I can do a preview. So I know I have the right swing. It looks like I want to do a positive 90 degree move in this case. I'm going to just start typing 90. So I'm going to hit 90 on the keyboard. I'm going to hit enter. That gives me a preview and it locks it in place. If I hit enter again, it'll confirm the input, which I'm going to do, and I'm going to click OK. When I hit right click top now, I should be seeing the top of the part, and that is perfect. Now again, just to orient this in space correctly, I'm going to look for my original top origin plane by hitting F9. F9 gives me the crosshairs. You'll notice that, we're out of whack a little bit, but that's fine. This is not going to be our WCS. This is just an orientation so that it's kind of set up by the base plane. We're not going to use the top plane here. We're not going to use this default top plane for anything other than just setting this place up in space. So I'm going to do a dynamic move again. Actually, let's do regular translate. So the next one over, translate. This has my vector from and to command, which I like to use. I'm going to use a pick box, left to right. Make sure I select everything. I'm going to hit end selection. And for this, I'm going to do from and to, which is on the left hand side in the translate space here. I'm going to hit reselect. I'm going to select a spot on the part first. So I'm going to put the vice, one of the vice corners up here on this top plane base origin. So I'm going to grab this area here, and then I'm just going to snap it. I want to make sure I change it to move and not copy, because we don't want to copy the plane when we the parts. We just want to move it. That's perfect. I'm going to click OK. All right, so again, that's just, we're not going to use that for anything other than that original positioning. So we're going to create planes going forward for the rest of this. At this point, I want to go ahead and save this file. I'm going to do File, Save. And then this is when you're going to want to use your naming convention, because you are going to submit this file to me. We'll talk about submitting the SOLIDWORKS file next as well. So I'm going to go find the file I'm working in. Here's my week 1 folder. And for me, again, this would be Parnell, which is your last name, underscore, and then the part. So this is the Geneva mechanism base plate. I'm going to go ahead and save that. Perfect. So before we do anything else, we want to look at our levels and try to figure out what we're dealing with here. I want to put the fixture, the 2 vice parts on a level. I want to put the parallels on a separate level. I want to put the part on a level, and then the stock on a level. So what we're going to do is kind of figure out what we're looking at here. So this right here is the level 1, looks to be the fixed base of the vice. Let's do vice fixed base. Number 2 is the movable vice jaw. Let's do this. So vice movable jaw. Number 3 is a parallel, so we'll just do a 1.5 inch parallel. Number 1. This one is 1.5 inch parallel. Number 2. This looks to be the part file, judging from the line that's being turned off there. So this is the solid part. And then number 6 is the stock. Okay, so as I started this, I realized I wasn't following my own convention. So remember to put the operation number in front of your levels that this applies to. So all of these apply to op 10. So I'm going to go ahead and put op 10 here in front of all these names. Now, we only have the 1 operation, so this isn't super critical to what we're doing. But you want to remember to do this every time, because eventually we're going to be doing multiple operations in a file, and it's going to screw you up if you don't do this. So I would like to move some of these combined. Like, it doesn't make any sense to have these parallels separated, for example. It's not critical. I think maybe we'll talk about that in the class next time, but for now I do want to leave this alone. I am going to select a couple of these parts. So what I'm basically doing is I'm left clicking. I'm going to left click on the vice parts. I'm going to right click, and then I'm going to change the solid color to something different to kind of just show that they're together but different things. You may have to clear colors to get it to show up. So now I had the vice as green. I'll turn the actual part file into, oh, I don't know, like yellow, something like that. And maybe I'll turn the stock blue, something like that. There, perfect. That's just some quality of life stuff. I'm going to hit save now. And that looks good. So we've created our layers, or our levels, changed some colors. Now what we're going to do is load in our tool, or our machine group. So inside of machine, we go to mill, which is on the very left hand side. If you're at stick, you would normally pick the STCC number 10, I believe. I forget how a numbering system works off the top of my head, but there's a 3-axis mill, a 4th-axis mill, a router. You would see all those load up. For what we're doing from home today, I'm just going to click on default. We'll start with that. Loads up the toolpaths area, and it also gives us the machine group 1 and properties here. I'm going to start by renaming the toolpath group by double clicking on toolpath group and renaming this to op10. You're better off probably doing that immediately as soon as you create the machine group so you don't forget to do that. So this is operation 10, and now we're going to go to stock setup. Stock setup, previously we did something a little bit different. This time, now that we have the solid model, stock is really easy. It's one of the reasons why I like to set it up like this. We're going to go to stock setup. I'm going to change the stock plane from top. Oh, we haven't created our plane yet, so we're not going to do that yet. Let's actually create our plane first. It's my fault, so we'll get out of stock setup. Let's create our plane first. I want the WCS plane in the bottom left-hand corner of the part, which means in order for us to get to that, we need to turn the stock level off, which is easy. So we'll go to levels, mine is number 6. Turn that off so I'm only seeing the base plate. And now we're going to go to the planes tab in the bottom left-hand corner. I'm just going to duplicate top because it's in the right orientation. All I want to do is change the position in the X and the Y. So I right click on top, duplicate. I'm going to rename the plane we just made to op10 G54. That's our first plane and our work offset. And we can go to the bottom now and change the origin positions. And the easiest way to do that is to click on the cursor, and we're just going to snap right to a point. I'm going to left click on the cursor, and I'm going to go ahead and click on the bottom left hand corner of the part, and Z0 is going to be on top of the part. Perfect. That's excellent. Now that we have that, I'm going to go up and I'm going to hit the equals sign, which is to set your current WCS and construction and tool planes all to that level. So that's perfect. And why don't we go ahead and save this while we're doing that. Now we're ready for stock. So I'm going to go back to levels and turn the stock plane on for a second. Go back to toolpaths, stock setup. I'm going to change the stock plane now to the G54 that we just made. I am then, instead of specifying anything in here, I'm going to go to solid mesh. I'm going to click the cursor icon to the right of that selection, and then I'm just going to go ahead and highlight the stock block. And that's all you got to do. You'll notice that the gray area now, it specifies the size, so you can double check. It's 4 by 6 by 3/4, which is correct. I'm going to hit display. For what we're doing, I'm going to leave it at wireframe, but you can change it to solid if you want to. It'll turn it into a translucent block. The wireframe is the red dashed lines that you normally see from the previous semester. So I'm going to click OK. And the position is off, which is interesting. Let me check that out for a second. Okay, so I bumped into an issue that I wasn't aware of. So in order for the solid stock to work the way we want it to, it has to be in line with the top origin. And I didn't set it up that way, so I'm going to show you how to reset it real quick before we move on. And then I'll remember this in the future, so we won't have to deal with this problem. So I need to move the part to the top origin, basically, which you see is way off here, over here in space now, because I've been playing around with it. Yours is probably somewhere over here. The easiest way to do that, I'm going to set top to be my active plane, and I'm going to go up to transform, move to origin. So with this selected, I'm going to click move to origin. and I'm going to select the bottom left hand corner of the part, and that's going to set up so that it's basically in line with my top. Okay, now doing that, I also need to make sure my G54 isn't wrong, which I think it might be. If it is wrong on your screen or on your file, what you're going to want to do is also go down to the cursor and make sure that you also have that on the bottom left hand corner of the stock. So basically your top plane and your Op10 G54 should be on top of each other, at which point you can now go back into stock setup and have Op10 G54 selected as your stock plane and the solid mesh selected there. If you get screwed up on that, don't worry about it. We'll come back to it and we'll talk about it in class too, so I'm not too worried about it at the moment. So with the stock setup, now we can get rid of the actual solid model. We're not going to get rid of it, but we're going to hide it so we don't have to look at it anymore. So it doesn't actually consume this. The solid is still there. It just kind of wraps a stock profile around it. So when I turn the Op10 stock setup off, now all we have is a translucent block above the main block here of the part. So I'm going to hit F9. I'm going to right click and clear colors, and that basically resets the color scheme. You'll have to do that fairly often. The colors get hung up when you're doing selections and things like that sometimes. So if your part looks like this, and your G54 is active, double check on that in planes. Yep, G54 is active. We are now at the point where we can start to machine the two features here, the facing and then the drilled holes. So I'm going to start that now by doing a facing operation. We have machine group 1. I'm going to go to toolpaths. We're going to go to facing. I'm not going to select a chain. Actually, for this we are going to select a chain because I think it will fail if we don't. In order to do that, though, we need to turn that solid back on. My apologies. So we'll turn the Op10 stock back on, and we're going to do a face. So you want to make sure that face is clicked, and we're just going to click on the top of that stock block basically and click OK. So for facing operation, we're going to go into Tool. I'm going to go in and select Library Tool, and I'm looking for a mill. Depending on whether you're at school or at home, you're going to see a different library. Remember, you can go in and choose different ones, but for right now I'm going to turn the filter off, and I'm just going to sort by diameter because the face mills are the biggest tools in the library, and I'm just going to grab this 2.5 inch face mill. You can take anything you want that's around a 2 inch. That should be fine. So 2.5 inch face mill. Speeds and feeds are automatically filled for us, and our comment is going to be face the part. It's going to be Z 0.0 is what we're establishing, and I may put in removing a 1/4 inch material just to tell whoever's looking at this what we're doing. For cut parameters, I'll do one way. We'll leave that alone. That's fine. The overlaps, distances, exit and entrances is all set. We're not going to change any of this. I am not going to leave any stock on the floor, so I'm going to change that to 0. For depth cuts, let's do a depth cut. So instead of a 1/4 inch, let's do 1/8 inch max. So hypothetically speaking, we should be getting 2 cuts. Max, so 1/8 inch, that's good. Linking parameters, same as always. So clearance is 2 inches absolute. Retract is a 1/4 inch absolute. Feed plane, I usually make that a 1/4 inch absolute. Top of stock should be a 1/4 inch. That's correct because it's 250 thousandths above Z0. But I'm going to go ahead and just click it anyway just to confirm that. Perfect. And then our depth is going to be an absolute 0 because we're establishing 0. So that's what's going to be at the top of our part right there. I'll go to coolant and turn flood on, and just confirm planes are right. So that should be everything. At this point we can click OK, and there's our two cuts, right? So yellow are feed moves or clearance moves, blue is our feed rate moves or cutting paths. I'm going to go back into planes and just turn off, or I'm sorry, levels, and just turn off that solid stock again. And I'm going to go ahead and back plot this. Just watch the cut. And again, make sure you're checking it from all angles. So I'm looking to make sure that my Z level is correct. It should be down at 0 here on the second move. That all looks good. We can confirm with top and make sure it's removing all the material, going over the sides. That's all good. There's no clearance issues with the vise. Very happy with that tool path. So I'm going to save that, and now we can start looking at doing the drilling. There are going to be 3 drilling operations to complete these features. We're going to have a spot drill, we're going to have a tap drill through, and then we're going to have a tap through. So just looking at the print, the drill through size is 0.15. We'll go filter the tools by that later on to get that. The tap is a 1024, and we're going to spot drill a little bit bigger than this 15. Let's go to 17 so that we actually break the edge and have a nice lead for the tap to follow. So like I said, we're going to start with spot drilling, which is going to be in the upper right hand corner or left hand corner. We're going to go to drill. I'm going to select my 2 points. Again, you want to zoom in and make sure you get the center point of these circles and not the quadrants. So there's 1, there's 2. At that point we're going to click OK. Now the most important thing here is to make sure we're using the right tool. So I'm going to go into the library. This time I'm going to filter instead. So let's go and turn the filter off for now. Actually, the center is right up top, so that's actually convenient. But let's go. If you need to use the filter, let's look at that and review it. So if you click on filter, we want to do none, which clears it. And then we're going to go looking for the spot drill icon, which is this one right here on the right hand side. So if we only want to see spot drills, you would come in here and select that. I don't use a tool diameter. That just usually screws you up. I just want to see all the spot drills. And we don't need anything big. We do want to go bigger than 1/8 of an inch, so I'm going to pick the 1/4 inch spot drill. Click OK. Reinitialize speeds and feeds. And then for a comment, I'm just going to put in here spot drill. The 2 tapped holes to, let's go to 0.17 diameter. So that'll be 20 thousandths bigger than the size of the drill. That's perfect. So in cut parameters, drill counterbore is the cycle that we want, so that's good. Linking parameters, we're going to go ahead, go with clearance to 2 inch absolute. Retract 0.25 absolute. Top of stock is now 0. Depth is going to be absolute, but we're going to use the calculator to figure out what our depth should be in order to get to the diameter that we want. I'm going to click on the calculator. Again, we mentioned the finished diameter is going to be 0.17. We're going to overwrite the depth because we want that depth to be static and not additive. So it looks like our depth should be negative 0.085. Going to do that. Turn the coolant on. Why not? Flood the coolant on, and then we'll click OK. Perfect. So this is going to be a little bit harder to see if it actually, we just want to double check and see if we can see the drill point going a little bit bigger than what the actual hole size is. If it does that, then I know we're in good shape. So it should be a little bit deeper. The drill point should be somewhere out here. Perfect. So there's our 2 spot drills. I'm going to exit the back plot. I'm going to hit save. And now we're going to go ahead and do our drill. Since the geometry picking is so easy on this, I'm not going to copy toolpaths, but keep that in mind if you wanted to copy it and use the same what do you want to call it, the pick points for the hole definition. You could have done that. You just copy and paste it. But for here, I'm just going to zoom in and grab the center of this hole again, and the center of this hole again. Click OK. Now we're going to do our drill. So our drill is going to be deeper, is going to be pretty deep compared to the hole size, which means we're going to peck drill. We're going to peck drill about half the diameter of the drill, or maybe 3/4. We can go a little bit more aggressive. So we'll probably peck it like 1/8 of an inch, and we'll go all the way through to the bottom. So inside of our tool, we're going to go select library tool again. I'm going to go ahead and go back into the filter and just filter it by drills this time. And it looks like drills should be, let's see, those are the tabs. There's the drill right there in the second row. So I want to see all the drills, and I'm looking for 0.15, and that's actually not the real size that we want. I think it's, yeah, this 5/32 drill, 0.156 is what we want. So 5/32 should be the tap drill size for a 1024. So I'll click OK. Our comment is going to be tap drill 2 holes through, and the plate is a 1/2 inch thick. So let's say a Z minus of 0.563, or let's just do 600 so it's easy to remember, and we'll do that in the tip comp. So tap drill 2 holes through, Z minus 600. Cut parameters, drill counter bore, we're going to change that to peck drill. And let's do a peck of 125 like we mentioned. So it'll cut 1/8 of an inch, and then it'll retract out and clear the chips, so on and so forth. Linking parameters, we have absolute 2, retract absolute 1/4 inch. Top of stock should be an absolute of 0 now, because that is materials removed. And then our depth is going to be the bottom of the solid. So for what we're doing, I'm going to go ahead and click on the bottom of the solid just to verify the depth. So I'm going to rotate and grab the bottom of the hole, -5, which is good. That matches the print. However, you will remember that we talked about having tip comp on, so we have some drill through. So I'm going to turn tip comp on, and our breakthrough amount, let's just do, it's going to be a little bit interesting because the tip length is this. So if we want a true 600, we can kind of fake it. Let's change the tip length to 0 and just change the breakthrough amount to 100 thousandths there. That should work. Hopefully it won't error out. But this is basically cheating it a little bit. Either that, or I can take this, copy the tip length, and do 100 minus the tip length in that box, and then that gives us that amount. So 0.053058 plus the tip length here adds up to 100 thousandths, which will make it Z minus 600. Way more complicated than it has to be. You could have also just ran it like this and then checked to see what the final Z length was, and then gone back to edit the note. But this is fine the way it is too. So we'll click OK there. That should be done. Well, we'll turn the cool one on too. Apply. OK. Now we're just going to go ahead and watch the back plot for the peck drill. There's the peck. That actually looks really good. And then I just want to make sure that it comes all the way down past the bottom of the part, which it does. That's perfect. So that should be 100 thousandths. The last toolpath we need to complete in order to finish this file is the tapping toolpath. So I'm going to go up and still use the same drilling command we have been using. I'm going to select these center points on the two holes as we did in the previous two. And click OK on that. So we're going to go to Tool, and we need to go find a 10/24 UNC tap. I'm going to go into the library. I'm going to use my filter again. So right hand tap is industry standard, left hand taps are the oddball ones. So right hand is what you're going to be used for the most point. Right hand is the most prolific, we'll say. We'll click OK. And now I'm going to, oh, you know what, I didn't turn the drill off. So I want to turn the drill off and only see the taps. So we said we needed a 10/24 right here. So for me it's tool number 216. Click OK. I'm going to say tap through two holes, and in this case our depth should be a 1/2 inch plus another 100 thou, so let's do 600 again. Z minus 600. Now that depends though, because we got to see how long this is, so let's double check and see how long the tap is itself. So the tap itself is 2 inches long, so that's perfect. No problems there. Cut parameters, so this is going to be a tap. That's good. Change the cycle to tap. Linking parameters, clearance of 2, retract an absolute 1/4 inch for both. Our depth, in this case, we already know what we're doing, so I'm not going to spend a lot of time looking at it. So -0.500 is our full depth. And for our tip comp, we want to use 0.100 thousandths for our breakthrough amount. And that gets us to our Z minus 600. In this case, there's no tip length offset because the bottom of the tap is flat. So that's why there's no tip length to that. And for this, we're not going to have any coolant on. We're going to turn the coolant off, actually, because we're going to use oil for this instead. We wouldn't use coolant. We put some oil in there. I guess you could use coolant if you wanted to, but for now, we're going to pretend that we're just going to put some oil in there before we start. So I'm going to click OK. And we're going to go ahead and watch that tool path. It's just going to go straight in. Going to make sure it comes out the bottom. And there we have it. So that completes this tutorial. I'm going to go ahead and save this file. And at this point, you'll be ready to submit it. I suggest you watch the next file in the series, or the next video in the series that explains how to submit both your MasterCAM file, which is easy, and the SolidWorks file, which has some extra steps to it this semester. So go ahead and watch that before you submit those two files in Blackboard. And then congratulations on completing week 1. So I'll see you in week 2.